Okay, we've done a bunch of these already, so I'm just going to do the front sides fast. Remember, cosine does cosine, cosine, and opposite pluses and minuses. Sine of 30 is the 1/2. And the angles for 45 degrees, the numbers are both √2/2s. When you're multiplying, you go straight across. Okay. At this point, you have to do something in the second quadrant. You can do 135 and 30. You can also do 120 and 45. Notice if it ends in a 5, chances are one of the numbers is 45 or a second quadrant or third quadrant version. Sine uses a mix, sine, cosine, and does not switch pluses and minuses. But it does switch from sine to cosine. Don't write sine of 135 twice. Uh, 135 is the second quadrant version of 45. The cosine has gone negative. Okay, so just be aware that the reason that this works is because if you look at 75 degrees, it's just short of 90, and the cosine is very small. If you look at 165, it's almost 180, and the height, the sine, is very small. And they're the same number. Not a coincidence. 15-degree angles. Okay, speaking of which, I'm going to take and flip cosine. So remember, secant is 1/cosine. So you can do 45 minus 30, or you can do 60 minus 45. Now remember, it's cosine, cosine, and then opposite. Little degrees signs. I sometimes get a little lazy about them. Don't forget the plus sign in between. It's cosine times cosine and then plus sine times sine. Is this the answer? No, this is not the answer. We want secant. And you can multiply by √6 minus √2 on the top and bottom, and I'm not going to bother. Pi over 4, pi over 3, pi over 6, pi over 2. Note, easiest way is going to be use pi over 6 and pi over 4. Does it matter which one you put first? No. Okay, next, let's find some double angle formulas. Before we do, we have to first of all make sure we're in the right quadrant. Okay, cotangent is cosine over sine. So it's x coordinate over y coordinate. This isn't right. It's in the third quadrant. What's the matter? Oh, they're both negative. So be careful with that. How do you know they're in the third quadrant? Because you have pi and 3 pi over 2. Let's mark them in. Okay. You find the hypotenuse. Don't forget to put parentheses around the negative numbers. Square root of 25 is 5. So the hypotenuse is 5. Always make the hypotenuse positive. We did that over and over again in previous units, so I'm not going to obsess about it. Tangent is just the reciprocal of cotangent, so that one we could have done without any other work. Sine I need to do. Sine is height. Oh, no, it's not, because it can't be bigger than 1. Remember, sine is only height on the unit circle. You have to do opposite over hypotenuse. So I'll write a note. Okay, cosine is adjacent over hypotenuse. Sine of 2 theta is 2 sine theta cosine theta. So we just stuff in the numbers that we just found. Sine of theta was negative 3 first. And we'll put the 2 over 1. 2 times negative 3 times negative 4 is positive 24 over times 5. Okay. There's 3 versions of cosine 2 theta. Every single one of them gives you the same answer, because they're 3 versions of the same thing. Okay, so for honors, in order to figure out sine of theta over 2, cosine theta over 2, tangent theta over 2, you have to figure out pluses and minuses by doing the following. Important. So first I'm going to rewrite theta is between pi and 3 pi over 2. Then I'm going to just cut everything in half. So pi over 2, theta over 2, 3 pi over 4. So where is that? It's between pi over 2 and 3 pi over 4. So theta over 2 is second quadrant. That means cosine is negative, sine is positive, and tangent is negative. Okay, so that's the little detail. So sine will be negative square root of thingy. Positive square root of thingy. Cosine and tangent will be negative in the second quadrant. Okay, so we have formulas for sine, cosine, and tangent. I'm going to multiply everything by 5. And I don't frankly care if we turn it into root 9 over 10 or root, 3 root 10 over 10. Ugh, simplification, whatever. So this is going to just be 1 plus 4/5 over 2. Sorry, 1 minus 4/5. It was 1 plus 4/5. 1 plus negative 4/5. So 5 minus 4 over 10 is... We can simplify that. Might as well. Okay, next. Sine part over cosine part. And the 2's cancel. So you just have square root of, let's see, 9/10 over 1/10. Or 9, whatever, 9/5. I guess those are fifths if you don't. Just make it in a 9, yeah, whatever. Okay, cancels anyways. Okay, so next problem, same thing. We're going to be looking at, okay, where's negative pi over 2 to 0? So we're in the 4th quadrant, so the sign is negative. Sure it is. Negative 3/5. And the cosine will be positive. For the half angle, when we get to the honors part, let's just look. Let's see. Negative pi over 4 to 0. So, I'm going to write it as cosine of pi of theta over 2. Otherwise, you'll think it's cosine of theta. Okay, so when we get down there, positive, write it a little higher because it seems like we need a little more space. Okay, cosine of theta is Pythagorean theorem. It's another 3, 4, 5 triangle. Positive 4 for this. Cosecant's the one that's really easy because it's just flipping the original sign. Tangent is opposite over adjacent. Okay. Sine of 2 theta is 2 sine theta cosine theta. Again, put the 2 over 1. 3, 4, 5 triangle twice. That's why we're getting the same numbers so often. Doesn't ask for secant, it asks for cosecant. This is flip sine, which we just figured out. Okie dokie, sine of theta over 2. 1 minus cosine of theta. So plus or minus negative in the 4th quadrant. That formula is on your formula sheet. So this time we have 5 minus 4. I'm multiplying by 5. Let me just do that out just once. Okay. So sign on top. And you can take the square root of that number, so I did.